Hello everyone. Okay, so in this video we're looking at the classification of functions. So a function can be classified or labeled three ways. A function could be called injective, surjective, or bijective. In order to do this, we first need to have a look back at some of our notation, our function notation, before we go on and start classifying functions. So it's very important now when we're working with function notations and leaving cert, we need to be familiar with our number groups. So n is the set of natural numbers, z is the set of positive and negative whole numbers, the integers, q is the set of rational numbers, which are fractions, or less q is the set of irrational numbers, e.g. pi and root 2, or is the set of real numbers, including all the numbers above. So or is the set of every single number, and then or plus is the set of all positive real numbers. And it's important to be very familiar with this function notation here. So, what's different between notation function that you probably learned in junior cert is you are given what the domain is and you're given what the codomain is. So this is a function such that the domain or real numbers mapped to real numbers. Then x is my input and this is my rule. So it's very important now we know what our domain and our codomain are of my function. So let's just have a look here, classifying functions. So let's start with injective functions. So what's it mean to be injective? So a function is classified as injective if, or one-to-one, if different inputs always give me different outputs. So each input has a unique output. So each input goes to its own thing in the codomain. So each input has a unique output. So let's have a look at this. This is Sarah, David, and Stephen, right? They're my domain, right? My codomain is a box of celebrations, a box of sweets, right? So if this would be injective, each of them would get their own unique sweet. No one would be getting the same sweet from the box. So Sarah would be getting Mars, David would be getting Snickers, and Stephen would be getting a Bounty. So each student has a unique sweet. So each input has unique outputs, therefore that's what it means to be injective. So a rule we can use, or a test we can use to test for injectivity, is called a horizontal line test. And a horizontal line test just means if I can draw a horizontal line through a function and it hits it more than once, then it is not injective. So looking at this function here, no matter where I draw the line, a horizontal line during no matter where I draw a horizontal line in this linear function, it only ever hits it once. Therefore, this function is injective. But this quadratic function here, well, I can draw the line here, here, or here, and it always hits it more than once. Therefore, this is not injective. So let's have a look at these functions here. So which of the following graphs is injective? So we have h of x equals x squared and f of x equals to e of x. Well, using my horizontal line test, I can see, well, this function is not injective because it hits it more than once, fails a horizontal line test. And this function here, f of x equals e to the x, the exponential function, well, this function is injective because no matter where I draw my horizontal line, it will only ever intersect once. Fine. Now let's look at surjective. Surjective means, or onto, means everything in my domain, everything in my codomain is hit by at least one thing in my domain. In other words, no one is left out. So imagine now, right? Let's go back to the box of sweets. So my domain is Sarah, David, Stephen, and my codomain is my box of celebrations. So, right, let's just add two more people here. So let's add Maria and let's add Aoife. Right? So two girls were late to class, right? I still have a box of sweets here. So Maria is going to come and grab the Maltesers. And then, oh, there's an extra Snickers in the box. So Aoife grabs the Snickers. So I now theoretically have an empty box of sweets, right? So basically, what this means is everything in my codomain has been used, right? My box of sweets is empty, right? I have heroes right here, right? I have no sweets left in my box. I have no sweets left, right? All the elements in my codomain have been taken by students, right? That is what it means to be surjective. Every element in my codomain is used, or in other words, the range of my function equals my codomain of my function. So let's look at these ones here. Which of the following graphs is surjective? So I have my function f, which maps real numbers to the positive real numbers. And my function is e to the x. So if we look at our plot here of e to the x, you can see from the graph, the range of y values is between 0 and infinity. So the lowest one it will go is 0. The highest it can go is infinity. So that is the range of my function. But if we see here, it says here in my function notation, my codomain is a set of positive real numbers. So if as the range is 0 to infinity, which is the set of positive real numbers, that is equal to my codomain. So therefore, this one is surjective. What about here? This one is we're mapping now for this exponential function. We're mapping. Sorry. So this is just a cubic function. My domain is the natural number. My domain is the natural numbers. So my range of the function goes from 0 to infinity. If we look back at my function notation here, my codomain is equal to all of the real numbers. So we can see from the graph, the range of y values is between 0 and infinity. As we are told, the codomain is the real numbers, i.e. minus infinity to positive infinity. The range does not equal the codomain. Therefore, the function h of x is not surjective. So we always have to look at range and codomain. And finally, bijective. A function is said to be bijective if it's both injective and surjective. So just something to know, every bijective function has an inverse. I'll be doing that in a later video. I.e., we can always work backwards from the outputs to find the initial input. So bijective, it's injective and surjective. It just means every input has a unique output and every output is hit at least, every input is hit once, right? It's 1-to-1, right? It's 1-to-1 and onto. Each input has a unique output and every output is hit once. So think of it like this. I'm handing out sweets to class. I'm handing out this box of sweets to class. And it's bijective if each student gets a unique sweet and the box is empty. So if I use every sweet in my box, each student gets a different sweet. So no two students get a Malteser sweet. No two students get a bounty, right? Each student gets their own unique sweet or unique flavor of sweet. But also I used every sweet in my box. That's what it means to be bijective. So let's look at this here. This is a graph of the function of my modulus. So OR maps to OR plus. So my domain is the real numbers. My codomain is the real positive numbers. Is my function f of x, is my function f surjective? Yes, it is, because my range goes from 0 to infinity, which is my positive real numbers. And that is my codomain. So my range is equal to my codomain. So therefore it is surjective. Is it injective? No, it's not injective. It fails the horizontal line test. It fails the horizontal line test because it can't draw a horizontal line and it intersects more than once. So suggest a restricted domain and range to make f bijective. So if I want to make the function bijective, right, I need to, well, it has the surjective thing down, so I need to make it injective. To make it injective, I kind of want to say, okay, what values of x will only kind of give me maybe this part of the function, like half the function here. And I could say then if I make my domain x an element of, say, the real positive numbers, or between 0 and infinity, right? Therefore, my function will be injective, because then I'm essentially erasing this side of my function, and I'm kind of only left with one half. And then this function here will be injective. And it's also surjective, so bada boom, bada bing, therefore it is bijective. Right, let's just look at one or two questions. So, examine the following functions and state, given reasons, whether each function is injective, surjective, bijective, or none. So, this is a function e to the x. The codomain is the real positive numbers. I'm looking at here. I know this function is injective because it passes the horizontal line test. And then is it surjective? It is surjective because my range is between 0 and infinity, which is my real positive numbers. So this one is bijective. Sorry, I change my pen size. That one is bijective. What about this function? Well, I see right away it fails the horizontal line test, so it's not injective. And then my range goes from 0 to positive infinity, which is not equal my codomain of just all real numbers. So I'm missing like half from there, so it's none. This is a function of none of them. This is my natural log, so L of n, ln. So it passed the horizontal line test, so it's injective, stunning. What about injective? Well, I'm looking at it here, and my function seems to be kind of going from minus infinity to plus infinity, right? It is going up. If we kind of keep that gradient, it will kind of max out, I suppose, at plus infinity. So that is equal to my codomain of real numbers. So it's injective and it's surjective, so therefore it is bijective. Then this is a function of sine of x. My inputs are the real numbers. My output, my codomain is just between -1 and 1. So let's see here. My range goes from -1 to 1. So range is equal to codomain. Stunning. It's surjective, but it fails the horizontal line test. So this function is surjective only. Right, let's just look at this question from 2023. So the graph below shows these three sets. Find the value g of f of 3. So I need to apply function f first to 3, which brings you to a globe. Now applying function g, and the globe gets mapped to w. So g of f of 3 is equal to w. Explain why function g is injective but not surjective. It's injective because every input has a unique output. That's correct. Every input has a unique output because the plane goes to x, the world goes to w, the rain goes to z. But it's not surjective because not every element in my codomain is used. Not every element of my codomain is used. We see here, nothing goes to the y. So therefore that's what makes it not surjective. If it was surjective, every element of my codomain would be hit at least. Right? Let's just look at some of these now. So this is a function f of x. It was equal to 2x. My domain is the natural numbers. And then my codomain is e, the set of even natural numbers. Is my function injective? Yes, it is, because I see here, if I start subbing in values 1, 2, 3, 4, this will give me an output of 2, 4, 6, 8, 10, which are my even numbers. So range equals codomain. So yes, it is. This one here is a set of even natural numbers. So is this one surjective? No, because if I start plotting this out where x equals 1, 2, 3, 4, 5, I'm going to get 4, 8, 12, 16, da 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 da. So it's nearly my set of natural numbers, but not all of them are being hit. So like I'm missing, for example, 2, 6, 10, etc. So no, range does not equal codomain. So not everything is hit in my codomain. Right, is this function bijective? This is a linear function, so it looks like this. Boom, boom, pass the horizontal line test. This is going to go to minus infinity up to positive infinity. So my range is equal to codomain, and it passes the injectivity test, the horizontal line test. So yes, it is. Is the modulus function injective? Explain, restrict your domain to make it injective. So, is it? No, because it makes a V shape, therefore it fails the horizontal line test. But restrict your domain to make it injective. Well, like I said in the previous example, I kind of want to get rid of half of that. So if x starts at 0, I want to say x is greater than 0. If x is greater than 0, it will only give me kind of this half of the function, and therefore it will make it injective. Right? Explain why this function x squared is not onto. Restrict the codomain to make it surjective. So because this is a quadratic, boom, 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 the range goes from 0 to infinity, which is not equal to my real numbers. So range does not equal codomain. Restrict the codomain to make it surjective. So to restrict the codomain to make it surjective, well, if I make now my codomain the real positive numbers, therefore that will equal my range. Because my range is from 0 to infinity, the real positive numbers is 0 to infinity. So therefore, the range will equal the codomain, and it will make it surjective. Right? 3 more, and then we're done. Is my function h onto? So surjective, sine of x. Is it? No. Because sine of x, right, goes from -1 to 1. So my range is -1 to 1. My codomain is the real numbers. These are not the same. Not equal. Not on. X is equal to e to the x. Restrict the codomain to make p onto, make it surjective. So e to the x, again, you kind of plot it out in your head. It goes from like nearly to 0 to positive infinity. So 0 to positive infinity. My codomain is or. So if I just make my codomain real positive numbers, therefore it will be surjective. And the final last one is e to the x bijective. Explain. Well, we were looking here, e to the x looks like this. It says now my codomain is the real positive number, so therefore my range will equal my codomain. So surjective, yes. And then bijective, because it will always pass a horizontal line test, so it's both injective and surjective, therefore it is bijective. Right, I'll catch you guys later. Bye.